Let's look now at 3 times 3x minus 2x to the 1/2 equals -1. First thing we need to do is distribute the 3. So we actually have 9x minus 6x to the 1/2 equals -1. And since these have fractional exponents, and we're going to try to solve them by factoring, since there's more than one term, let's get it equal to 0. So we have 9x minus 6x to the 1/2 plus 1 equals 0. So take a couple of minutes and see if you can figure out how to factor that. So let's see if we can get that factored. 2 parentheses equal to 0. I know that I'm going to split the x's into x to the 1/2, x to the 1/2, but I have to figure out how to split the 9. So let's try 3x to the 1/2, 3x to the 1/2. Our only options are 3 and 3 or 1 and 9. So let's try the 3 and the 3 first. Then I need both negative, and the only factors that multiply to the end to 1 are 1 and 1. So let's check and see if that works. 3x to the 1/2 times 3x to the 1/2 gives us 9x to the 1. Outer and inner are both negative 3x to the 1/2, which gives us negative 6x to the 1/2. And last times last would give us positive 1. So it does check out. It turns out in this case, we got the same factor twice. So we'll set each one equal to 0. But since they're the same, we really only have to do it once. So we know that x to the 1/2 equals 1/3. And then we raise both sides to the reciprocal power. So the reciprocal of 1/2 is 2, so we're going to square both sides. And that tells us that x to the 1 equals 1/9. Do we have to check it? Yes. So let's go to our calculator. Let's store 1/9 for x, and let's check it. So we'll use alpha y equals 1/9. We will store that for x. And then the original problem was 9x minus 6x to the 1/2. Be sure you drop all the way back down. That was the left side of the original, right guys? Okay, so if we hit enter, what should it equal? And it does. 1 or -1? -1. And that is what the right side equals, so we know that we checked it and it works. So we are done with this problem. Example 3 is a radical equation. Radical equations are different from polynomial or rational exponent equations. We're not going to solve them by factoring. There's a whole lengthy process for solving radical equations, so we're going to talk through it. The first thing we want to do to solve a radical equation is we want to isolate a radical. If there's more than one radical, pick one to get by itself. Once you isolate a radical, you want to raise both sides to a power. You choose the power based on the root of the radical. So if it's a 5th root, you would raise both sides to the 5th power. If it's a square root, you would raise both sides to the 2nd power. So the second step is to raise both sides to the appropriate power. Step 3. If all of your radicals are gone, solve what's left. But if you still have a radical left, start over. So if you still have a radical, you start over. We'll look at an example of one of those. And finally, you have to check your solutions. You must check for extraneous solutions. Just like we have to check the ones that have x to the 2/5 and x to the 1/2 and all of that, you also have to check these. So those are the steps we're going to use to solve radical equations. Let's take a look now at the square root of x plus 3 minus 4 equals 7. According to the notes over here, we should isolate the radical. So that means I first need to do what? Add 4 to both sides. That will produce the square root of x plus 3 equals 11. Once the radical is isolated, we should raise both sides to the appropriate power. Since this is a square root, we are going to raise both sides to the second power. We're going to square both sides to undo the radical. It's important to remember that you have to square the whole side. You can't square in pieces. We'll talk about that in the next example. The whole side is raised to the second power. Now on the left, the x plus 3, the square root of x plus 3 squared, the square and the square root undo each other, leaving us just with x plus 3 equals 121. Subtract 3 from both sides, and it looks like x equals 118. Then you need to go to your calculator, store and check. Give you a second to do that. Okay, so we all checked, and we got that 118 does make it true. So that is our answer to this problem. Let's take a look at this example. It's a little more difficult. We have the square root of x plus 3 is equal to 3x minus 1. The good news is the radical is already by itself, right? It's already isolated. Yeah? So all we have to do is raise both sides to the appropriate power. So here's where a lot of people make their mistake. Square the left, square the right. Well, what's the right side? It's a binomial squared, and you're not allowed to square individually. You can't just say, oh, let me square the 3x and let me square the negative 1. That won't work. You have to actually square the entire binomial either by foiling it or by using the square double square shortcut. Left side's not too bad. We get x plus 3. And the right side square double squares out to 9x squared minus 6x plus 1. So the good news is that all of our radicals are gone. We don't have to start over. We can just solve from there. Now what we have here is a quadratic equation. So I'm going to get it equal to 0 and see if we can figure out the best way to solve it. So I'm going to subtract x and subtract 3 from both sides. That gives me 0 equals 9x squared minus 7x minus 2. Do you guys want to factor that one with bottoms up? And try it, see if it'll factor? Okay. So we multiply the 9 by the negative 2. And that gives us x squared minus 7x minus 18. So I need two numbers that multiply to negative 18 but subtract to negative 7. So that seems like we should use x. 9 and 2. 9 and 2. This one negative, this one positive. And then we have to remember to divide back through by what? 9, yes. Divide by 9, divide by 9. The first factor reduces to x minus 1, but the second factor goes bottoms up to 9x plus 2. So if I set each one of those equal to 0, I get x equals 1 and negative 2/9. So let's pause here, go check those and see if they both work. So we checked, and x equals 1 does work when we substitute it back in, but x equals negative 2/9 doesn't, which means we have to discard that as an extraneous solution. And this equation really only has one answer. X equals positive 1.